Morty, give me a beat.
Oh man, okay,
Alright, so yeah, this is going to be your Trig Identities test review. I hope you like it. I hope it helps. Let's get started. Alright, number one here says solve for all solutions. 2 cosine x minus square root of 3 equals 0. Alright, we're going to isolate cosine. We're going to start by adding the radical 3 on both sides. Alright, so I add the radical 3 on both sides. Alright, so that gives us 2 cosine of x equals radical 3. And now, alright, so now what we want to do is divide by 2 on both sides. So we end up with cosine of x equal to radical 3 over 2. Alright, and so what you do then is look at your unit circle and figure out the exact values where cosine x equals radical 3 over 2. Alright, and that's going to be power over 6. And let's see here, 11 power over 6. Alright, you don't want to, make sure you don't use the negatives right here because that was an add, subtraction, plus or minus, because we can take the square root on both sides. Alright, anyway, let's keep going. This one right here, first off, if you look at this, this needs to be changed. Reason being, you can see how this is sine of x. I can't convert that, but I can convert this, alright, to 1 minus sine squared. Man, what is wrong with this thing? There we go, 1 minus sine squared. And that comes from the Pythagorean identities that we did in class a while ago. And then we have plus sine of x equals, right here you have 1. Actually, you know what I'm going to do? Well, here, let's go and bring the 1 over here to this side as well. We'll move everything over to one side. So, sine of x minus 1 equals 0. Now, the reason I did this is because you see 1 minus 1, that cancels, right? So I'm left with right here negative sine squared of x plus sine of x equals 0. Now, what we can do right here is we can factor out a negative sign, alright, or sign, because they're equal to each other. Because they're the same identity and they have the greatest common factor, alright, which is going to be sine. So if I factor out a sine x, I'm left with right here negative sine x plus 1. So now I take each factor and I'm going to set those equal to 0. Alright, then this one we're going to solve for sine. So subtract 1 and divide by negative, you get sine x equals 1. Alright, so you have sine x equals 1, and again, this was this one, because if you subtract and divide by negative, that's negative 1 divided by negative, which is positive. So now you look at your unit circle again and go, where does the sine value equal 0? Well, this one is 0 pi, 2 pi, and pi. Alright. This one, where the sine equal 1, that's going to be power over 2. Alright, power over 2. For this one, again, let's factor out a sine. Let's use another color right here. So let's see here. We factor out a sine right here. Sine squared, actually. Let's factor out a sine squared because the greatest common factor right here is sine squared. I'm left with 2 sine x plus 1 equals 0. So right here I have sine squared of x equals 0. You set your 2 factors. Sine x plus 1 equals 0. So this one I'm going to square root both sides because I need to get rid of that. I need to isolate just the sine identity. So the square root of 0 is 0. This one we're going to subtract 1 and divide by 2. So sine x equals negative 1/2. So now what does sine equal 0? Well, let's see here. 0 pi, 2 pi, and pi. And where the, oh, by the way, guys, if you have 0 pi, you have 2 pi as well. 360 are both right here. 0 degrees and 360. Same spot. So same x and y value. All right. Anyway, whether sine equal 1/2 or negative 1/2, it's going to be on the lower half of the graph. So we're going to have 11 power 6. And we're going to have 7 power 6.
Just hit a button, Morty.
So
Give me a
there's the
beat.
lower
Oh,
half
man,
right
okay,
there.
all right.
All right. This one. Let's see. All right, let's multiply both sides by 4 sine of x. And the reason being is so I can cancel this out. So I have 1 on the right side, and on the left, 4 sine of x squared equals 1. So now I'm going to divide both sides by 4. So sine squared of x equals 1/4. And now square root both sides. Sine squared, I square root, so there's no more sine squared. So sine equals square root the top, square root the bottom. By the way, you got plus or minus whenever you take square root on both sides. Square root of 1 is 1. The square root of 4 is 2. So we have positive 1/2 and negative 1/2. Sine of x is positive 1/2 and negative 1/2. And so you just saw, man, basically this is going to be everywhere that sine is 1/2 or negative 1/2 period. So those exact values are going to be power of 6, 5 power of 6, 7 power of 6, and 11 power of 6. Because positive, positive, negative, negative, positive 1/2, negative 1/2. All right, for 5. 5, we need to, let's see. This is going to be a trinomial. Let's get everything to one side. So sine squared of x minus 3 sine of x plus 1 equals 0. So now what I like to do and what I've showed you guys in class is make your 2 set of parentheses. All right. Now, what times what? All right. What factors will give me 2 sine squared of x? Well, if I multiply 2 sine of x times sine of x, right? 2 sine of x times sine of x, that'll give me 2 sine x squared. And now, what factors can I multiply to get 1? Well, if I multiply 1 times 1, 1 times 1 is 1. And so now we check ourselves. All right, 2 sine of x. Or let me do another
Just
color.
hit a button,
This
Morty.
is
Give me
just
a
a check
beat.
to
Oh,
make
man,
sure.
okay, all right.
Gotta check yourself. 2 sine of x times sine of x is 2 sine of x, sine squared of x, and this is foiling, guys. 2 sine of x times 1 is going to be a positive 2 sine x. 1 times sine of x is 1 sine of x, and 1 times 1 is 1. But you see this 2 sine of x and 1 sine of x equals 3 sine of x. All right, well, that didn't work, right? Because that's positive 3. 2 plus 1 is 3. I want negative 3, which means I need to change something right here, all right? And I need to get positive 1, so how about negative 1, negative 1? All right, negative 1, negative 1. So what that changes is right here. All right, 2 times negative 1 is negative 2 sine of x, and negative 1 times sine is negative sine of x. That'll give me negative 3 sine of x in the middle, which is what we want right here. So this works. Those are my factors. So now that I know what my factors are, I can go ahead and conclude my problem. All right. And how I conclude my problem is, now as we did with the last couple problems, we're going to set each factor equal to 0. So this one will give me sine of x equals 1, because you add 1 to this side. This one I add 1, then divide by 2. It's going to give me sine of x equals 1/2. Now, what does sine equal 1/2? Pi over 6, the top of the graph, and 5 pi over 6. And where does sine equal 1? Pi over 2. Alright, so here are our solutions right there. Alright, the last one of these type problems where we find exact answers. Alright, so this one, let's go ahead and take this. It's already factored for us. So we're going to set each factor equal to 0. You have cosine 2x equal to 0 and 2 cosine x plus 1 equal to 0. This one, what you need to look at first is where does cosine x equal 0? Well, cosine x equals 0 at pi over 2
Just hit a button, Morty. Give me a beat. Oh, man. Okay.
and
All right.
3 pi over 2. Alright, 3 pi over 2. So now I take this 2x and set it equal to pi over 2 and 2x equal to 3 pi over 2. And I solve for x. So I'm going to multiply by 1/2 on both sides. And this one, the 2 to cancel, so it's just x equals pi over 4. And for this one, multiply by 1/2 on both sides again. 2 to cancel, so I'm left with x. And right here, 3 pi over 4. Alright, 3 pi over 4. So that's this first half. For this half, I need to subtract 1 and divide by 2, so you'll know what cosine x equals to negative 1/2. What does cosine x equal? Negative 1/2. It's on the left side of the graph, so 2 pi over 3. And 4 pi over 3. Alright. Now, number 7 through whatever, I don't know what that is, how far that goes, but we need to simplify these. So simplifying means, guys, just take trig identities that you know and just convert until you can't convert anymore. Just try anything. All right, try anything. So right here, secant 1 over cosine. All right, again, just try anything. Cotangent is cosine x over sine of x. And if you notice, cosine and this cosine will cancel, and I'm left with 1 over sine x, which is cosecant x. Right here, all right, we have cosine, cosecant, secant. So here's what I'm going to do. I'm going to write cosine as cosine times cosine. I'm going to write cosecant as 1 over sine. And I'm going to write secant as 1 over cosine. Now, I want you to notice that I have a cosine at the top and the bottom, so I can cancel those out. So I'm left with cosine times 1 times 1, which is cosine, and sine at the bottom. Cosine over sine is going to be cotangent. All
Just
right.
hit a button, Morty. Give me a beat. Oh, man. Okay.
9. All right. Let's start over here on the right. I'm going to convert this to sine x over cosine x times sine of x. Alright, I converted tangent to cosine over cosine. Now I can multiply this because this is multiplication. So sine times sine squared over cosine. Now, I have a fraction on the right. In order to do that, I'm going to put this over 1, and the reason I'm doing that is because I'm going to get common. This has a cosine in the denominator, so I'm going to put cosine in this denominator, and if I do that, I've got to multiply at the top as well. So that gives me cosine squared, x at the top, alright, still plus sine squared, alright, squared for that, cosine times cosine squared, all over cosine. Because I have the same denominator. I have the same denominator, so I can put it all over the same denominator. Now, cosine squared plus sine squared, if you remember your Pythagorean identity, is 1. And 1 over cosine. So when 10. 1 minus sine squared. Alright, 1 minus sine squared can be converted to cosine of x because of the Pythagorean identity over cotangent x. Well, I'm going to rewrite cotangent x as cosine over sine. So cosine x over sine of x. Alright, I'm also going to rewrite this cosine actually, guys. I want to rewrite it over 1 so you can see a fraction over a fraction. Alright, so I have cosine x over 1 divided by cosine over sine. We keep, change, flip those. Keep, change, flip. We have a fraction over fraction. So you have cosine of x over 1 times sine x over cosine x, right? You can now cancel out your cosines. Make sure you flip this. And that gives me sine x over 1, which is sine of x. Alright, number 11. Number 11.
Just hit a button, Morty. Give me a beat. Oh man, okay.
Tan squared of x minus secant squared of x. That is a Pythagorean identity itself. That's 1. I'm not even going to spend a lot of time on that. Because the Pythagorean identity says that tan squared x plus 1 equals secant squared of x. Actually, that's negative 1. And I just realized it. So if I bring secant squared over here, that'll be tan squared of x plus 1 minus secant squared of x equals 0. And then if I subtract 1 on both sides, tan squared of x minus secant squared of x equals negative 1. So that's negative 1. Over here, let's see here. So this cosine over 1, cosine x over 1 times tangent, which is sine x over cosine x, plus sine x over 1 times cosine x over sine of x. Now I converted everything because, well, I can cancel out some stuff like that's multiplication right here. So I can cancel out the cosine. I'm left with sine x over 1. Over here, the sines cancel, so I'm left with cosine x over 1. Alright, so this is just sine x plus cosine of x. That doesn't simplify anymore, guys. Alright, it is what it is. You got to come to level 1, so there's nothing to use there. Or convert. Alright. Now, right here, cosine squared, tan squared, cosine squared. Alright, we have cosine squared plus, I want to convert tangent squared to sine squared x over cosine squared of x times cosine squared of x over 1. Well, if you notice, that cancels. So I now have on the left side of the plus side cosine squared of x, and on the right sine squared of x. Well, your Pythagorean identity tells us cosine squared plus sine squared is 1. Alright, and lastly on this type, we have cosecant. Ooh, this is a factor. We can factor right here. See how there's a cosecant here and a cosecant over here? Alright, so we're going to factor out the greatest common factor. So cosecant x, I factor that out. Alright, so cosecant times 1. See, cosecant times 1 would be cosecant. Minus, bring your minus sign down, don't forget that. And cosecant times cosine squared will give me cosecant cosine squared. So now, let's convert this. This is sine squared because of the Pythagorean identity that we know of. And I'm actually going to go ahead and convert cosecant as well. Let's rewrite cosecant as 1 over sine. So I have 1 over sine times, I'm going to expand sine x so you can see that I have 2 sine x's over here at the top, right here. That's sine squared. That cancels, so I'm left with just sine x over Alright, let's keep it going to the back side. Cotangent squared times secant squared. Well, cotangent squared is cosine squared over sine squared. And secant is secant squared, is cosine squared. 1 over sine squared, which equals cosecant squared. This one's fun. Yay or nay, you decide. Oh yeah, this one's fun. I think it's fun. Alright, so we need common denominators. So this one has a 1 plus sign, this one's a 1 minus sign. I'm going to multiply 1 minus cosine, excuse me. Good night. 1 minus cosine over here on the left. So I'm going to do it at the top. And over here, I'm going to multiply by 1 plus cosine of x. So now, at the bottom, our new denominator. Our new denominator is going to be 1 plus cosine, 1 minus cosine. That is, look, the same thing with different signs. The difference of two squares, but there was 1 minus cosine squared of x. I'm going to come back to that in a second.
Just hit a button, Morty. Give me a beat. Oh man, okay, all right.
So now, what you want to do is you need to distribute at the top. So I need to do sine times 1. Sine times, and put my minus sign right here, sorry. Now do sine times cosine. Right? And now over here, I got this plus right here. So I'm going to do sine times 1 is sine. And sine times positive cosine is going to be sine. Sine x cosine x. Alright. Now, what we want to do is simplify as much as we can at the top. And if you see, sine x and sine x will give me a 2 sine x. Alright, and then right here, you see that's a positive sine x cosine x and a negative sine x cosine x. Those cancel. Now, I can rewrite 1 minus cosine squared of x. If you remember, 1 minus cosine squared of x is going to be sine squared of x. So at the top you have 2 sine of x over. Now, remember sine squared is sine times sine. And I wrote it like this so I can cancel that out. So I'm left with 2 over sine x. Alright, and remember, I'm going to rewrite this as 2 times 1 because that's still 2. So you can see that 1 over sine is cosecant. You still got that 2 right there, so 2 cosecant x. Alright. Or you can just rewrite it as 2 cosecant x. It's the same thing. Alright. Just I wrote it so you understand 1 over sine. 1 over sine is cosecant. So 2 cosecant x. Alright. This one here. Verify. Okay, verify each identity. So we're going to make this side equal to this side. Make the left equal to the right. And how we're going to do that again is, I think, just like we did with 16, we're going to get common denominators. So 1 plus cosine of x at the top and the bottom. And 1 minus cosine of x at the top and the bottom.
Just hit a button,
so
Morty,
right here you get 1 plus cosine of x at the top right here, plus that one, 1 minus cosine of x. And then at the bottom, again, this is the difference of two squares, right? So you have 1 minus cosine squared of x. Now, at the top, can we cancel out anything? Can we rewrite anything? Well, yeah, we got cosine and negative cosine. And 1 plus 1. Alright. By the way, this is supposed to equal 2 cosecant squared of x. So 1 plus 1 is 2. And And 1 minus cosine squared can be written as sine squared. So just like we did with the last problem, alright, we can rewrite this, alright, because remember that's times 1, so 1 over sine squared is cosecant squared, and we still have that 2, so 2 cosecant squared x equals 2 cosecant squared of x. So this checks out, so we just verified that. Alright, for this one, we're going to make this left side equal this side, alright? So I'm going to start by factoring out a cosecant squared, because there's a cosecant squared here and a cosecant squared right here on both sides of the minus sign. Alright, so when I take out a cosecant squared x, right here I'm left with 1. Don't forget your minus sign. Alright, sine squared of x. Now, and we're saying that equals cotangent squared of x. So now 1 minus sine squared is cosine squared of x. And I'm also going to rewrite cosecant squared of x is 1 over sine squared of x. And I just keep rewriting this because we got to remember this side has to eventually equal that side. So now we can rewrite this. Alright, well, cosine squared x times 1 is cosine squared of x, and we still have sine squared of x in the denominator. And then this right here equals cotangent cosine squared over sine squared is cotangent squared, which equals cotangent squared. So we just made the left side equal the right side, okay? Now, these next couple problems are review questions. They will be on your test as well as on your midterm as well as on your county final exam. So let's do it, man. It says solve the triangle if possible. So given, and we got this triangle, I'm just gonna make a quick sketch, man. Let me see. Yeah, right there. There's my tool. So we have D. Alright, so I'm gonna go DEF. So big D is 34. Little d is 9. And little e is 14. So this right here is going to be side-side angle. So, ayo, we definitely got to check for an ambiguous case. If you remember with side-side angle, you have to check for the ambiguous cases. Reason being, well, you know why. You got to check the height. Alright, so H equals B 14 sine of angle A. Alright, so when I do that, we got 14 sine of 34. That gives me 7.8. So 7.8 is less than 9. Alright, but so right here you see that that side is less than 8, but A is still less than that side right there, the adjacent side. So man, this means two triangles. There's two triangles here. So what you have to do is use law of sines to find like this missing angle right here. Find angle E. So if I went 9 over sine of 34 equals 14 over sine angle E. Alright, and then we cross multiply 14, or actually we're going to end up with 14 sine of 34. Alright, and then we're going to divide that by 9, and then we take the sine inverse of that, and that gives us 60.4. So E equals 60.4 degrees. Alright, now I got to find my other E. Alright, so I'm going to do 180 minus 60.4. And that gives me 119, 180 minus 60.4. Gives me, that's E1 and then E2. So E2 is 119.
Just hit a button, Morty. Give me a beat.
So that's my
man.
other.
Okay, all right.
Now, I just got to find, see, because here's the other triangle. I'm just going to set it up. All the values are the same, 34, 14, 9. So this right here, this E is 60.4, and this right here is 19.6. Alright, and now I do 34 plus 119.6 is 153.6. And this angle right here is going to be 26.4. This angle right here is going to be 34 plus 60.4. 180 minus 90.4. This angle right here is 85.6. And so here I just got to find this small f. So I'll use law of sine. So 9 over sine of 34 equals f over sine of 85.6. So 9 sine of 85.6 divided by sine of 34 will give me 16.04. And then over here, I just do the same thing. I gotta find this little f over here. So I would do again 9 over sine 34 equals f over sine of 26.9. So 9 sine of 26.9 divided by sine of 34 equals 7.28. So this triangle and that triangle are completed. One triangle, solve if possible. Let's see here. E, F, G. E is 65. Little f is 12, and E is 8.
Just hit a button, Morty.
So again, we gotta check the height because this is side angle. This is not an inclusive angle. So H is going to be 12 sine of 65, and that's 10.87 or 10.9. So 10.9 is going to be greater than 8. So the opposite angle right is greater than 8. So this is no triangle right here. That's no triangle. Alright, last problem right here, man. This one, man, simple word problem. Just gotta read it. Check this out. Abram and June are sitting on the front porch of the storm. They notice a tree in the yard is leaning towards the house. So they're sitting over here, right? They're sitting here. Abram and June. Alright. The tree is 8 degrees off the vertical. Alright. It's leaning towards the house. So check this out. If I had a vertical, right? Let me just draw a quick vertical line. Alright. And the tree is leaning off the vertical. It's leaning towards the house. 2 pieces of information we need. 8 degrees off the vertical. So this is 90, right? This is 90. Here's a triangle. Well, it's leaning 8 degrees towards the house. Alright? Towards the house. They're sitting up on the porch. They're leaning 8 degrees towards, the tree is leaning towards the house. So this is 90, and that means this is leaning 98 degrees, because 90 plus 8 is 98 degrees. Alright, so when we actually draw this triangle, this angle right here is not 90, it's 98 degrees. Alright, because it was 90 plus 8. Alright. Now, it says if the tree is 67 feet, if they're 67 feet from the tree, so this way, 67 feet from the tree. All right. Estimate the angle of elevation from the top of the tree to. Estimate the angle of elevation to the top of the tree is 29 degrees. So from their angle to up here is 29 degrees. It says, will the house be hit? So we just need to figure out how long this tree is, all right? Because this is 180. So if you do 180 minus 98, well, this is 82 degrees, right? Right? So 82 degrees. So we just need to figure out what this height is. And we can do that by making a complete ratio, but we first need to figure out what this value is right here. So 180 minus the sum of those two angles, so 29 plus 82. That's 69. So this angle right here is 69 degrees. So now we can do law of sine. You have 67 over sine of 69 equals h. We don't know that side length over sine of 29. So 67 times sine of 29 divided by sine of 69. Alright, it's 34.79 feet. So h is 34.79. So if this fell, and remember at 67 feet apart, it's an F. If this fell, it would not hit their house. Alright? It wouldn't hit their house. So that's the question, because the question says, will the tree hit the house if it fell? Nope. It's too short. Alright, they're 67 feet away. This is only 34 feet, so it won't hit the house. Alright? That's how tall the tree is. Okay. So, hey, yeah, that's it. Again, I hope this helps, and I hope you like it. Good luck.